Question 1. A political candidate has asked you to conduct a poll to determine what percentage of people support her. If the candidate only wants 0.1% margin of error at a 95% confidence level, what size of sample is needed? We will need to use the following formula. N equals p hat times the quantity 1 minus p hat times z over the margin of error squared. Now let's figure out what p hat is. Now in this case you do not tell us what p hat is. P hat is unknown. If p hat is unknown, always assume that p hat is 0.5. If p hat is not given, let's assume p hat is 0.5. Now to find E, that's our margin of error, it's 0.1%. So let's convert that to a decimal. We move the decimal place 2 times to the left. That's going to be 0.001 for the margin of error. Now all we need to do is find our Z. To find our Z, we'll use the t-table with our 95% level of confidence. Again, to find the column, we use 1 minus the level of confidence divided by 2. We have 1 minus 0.95, which is our level of confidence, divided by 2. And this is equivalent to 0.025. That's the column that we will use, 0.025. For the row, we will use row Z. And that means our Z is equivalent to 1.960. Z equals 1.960. So now all we have to do is plug in our numbers to solve for the sample size. N is equal to p hat, which is 0.5, times 1 minus p hat, 1 minus 0.5, times 1.960 divided by our margin of error, 0.001, and we're going to square that quantity. Let's type this into our calculators. This gives us 960,400. So we need 960,400 individuals in our sample size so we can be 95% confident with a 0.1% margin of error. Just to make sure this answer is correct, let's go to our calculator. I'm going to look at the sample size calculator for a proportion. Let's put the margin of error, which is 0.001. The confidence level is 95, so let's enter 0.95. And we're going to calculate N. N is 960,365. Now this number is slightly different than our number, but that's because the computer is more accurate. But our answer is very close to this, so we know we did it right. Question 2. According to the Oxnard College Student Success Committee report in the previous year, we believe that 25% of students struggle in their classes because they don't spend more than 8 hours studying independently outside of a 4-unit class. For this year, you would like to obtain a new sample to estimate the proportion of all Oxnard students who struggle in their classes because they don't study enough outside of the classrooms. You would like to be 99% confident that your estimate is within 4.5% of the true population proportion. How large of a sample size is required? Do not round mid-calculation. In this question, we are given a p hat. P hat is 0.25. That's our prior estimate. Now we are going to use the formula. N equals p hat times quantity 1 minus p hat times the quantity z over e quantity squared. Now p hat is given, that's great. Now we need to find z. To find z, we'll use our t-table and use our 99% level of confidence. Let's go to our t-table. Here is the formula for the column. We use 1 minus the level of confidence divided by 2. Now in our particular problem, we're using a 99% level of confidence. So let's do 1 minus 0.99 divided by 2. Let's calculate this number. You should get 0.005. That's the column that we're going to use, 0.005. For the row, we'll use the last row, that's row Z. And here's our Z, 2.576. Again, Z is 2.576. And we need one more piece of information, that's our margin of error. Our margin of error is 4.5%. That's the E. Convert that to a decimal, move it 2 decimal places to the left, and this is equivalent to 0.045. So now we can plug in all the information. N equals P hat, which is 0.25, times the quantity 1 minus 0.25, times E, times Z, which is 2.576 over 0.045, and we're going to square this expression. So let's type in the entire thing on a calculator, and you should get 614.4237. But remember, we're talking about people. You cannot have a fraction of a person. So let's round this to the nearest whole person. This rounds up to 615. Remember, you always round up. When we're talking about the minimum sample size, we have to round up to include that minimum. So it's 615. We need a sample size of 615 individuals so that we can be 99% confident within a 4.5% margin of error. Let's check our work. I'm going to the sample size calculator for a proportion. Let's put 0.25 for the prior estimate. Make sure you click that you do have an estimate. The margin of error is 0.045. And we're looking for a 99% confidence interval, so enter 0.99. Click calculate, and we get exactly the same answer, 615. That confirms we are correct. Question 3. The Affordable Care Act, signed into law by President Barack Obama in 2010, was the most significant regulatory reform of the United States healthcare system since the passage of Medicare and Medicaid in 1965. The law was designed to expand insurance coverage and reduce the cost of health care. Some elements of the law, such are banning insurance companies from denying coverage to people with pre-existing conditions, are popular, while other provisions, such as the individual mandate, are unpopular. Opinions on the law vary, with some wanting to keep the law as it is, others favoring fixing the law, and some favor repealing the law in its entirety. The middle position has been gaining traction recently, and in the Rasmussen reports, poll conducted January 5, 2017, 599 out of 1,070 randomly selected likely voters want Congress and the President to fix the law a piece at a time. Part A. Find the point estimate for the proportion of Americans who want Congress and the President to fix the law a piece at a time. Round your answers to 4 decimal places. Recall, P hat is equivalent to X over N, the number of successes divided by the sample size. Here we have 599, and we'll divide it by the sample size, 1,070. This gives me a value of 0.5598. And again, we have to round to 4 decimal places, so that's our solution. 0.5598. For part B, we want to find the margin of error for a 95% confidence interval. To do that, we'll look at the formula. we know p hat plus or minus z times the square root of p hat times quantity 1 minus p hat over n is our formula. Now, which part of this formula is the margin of error? This part of the formula is the margin of error. So to calculate the margin of error, I need to find z. Let's go to our t table to find z. The column formula is equal to 1 minus the level of confidence divided by 2. So we are going to do 1 minus 0.95. We have a 95% level of confidence in this problem. And then we'll divide it by 2. This gives me 0.025. That's the column that we're going to select for a 95% level of confidence. And now we're going to use row Z to find our value of Z. This is 1.960. So Z equals 1.960. And we know that the sample size is 1070. Well, p hat is given in the previous problem. P hat is 0.5598. So we have everything that we need. Let's plug in everything into the formula. Z times the square root of p hat times the quantity 1 minus p hat over n. Recall Z was equal to 1.960. N was equal to 1070. And p hat is equivalent to 0.5598. Let's plug it in. I have 1.960 times the square root of 0.5598 times 1 minus 0.5598 divided by the sample size, 1070. Now let's enter the entire expression into our calculator. This gives me a margin of error of 0.0297. This is our margin of error. So in part B, our margin of error again is 0.0297. All we had to do was calculate the right part of the formula. In part C, we want to construct a 95% confidence interval, so we'll use the previous formula. We already know p hat, that's 0.5598, and we'll add and subtract the margin of error, which we already calculated in part B. That's plus or minus 0.0297. This will give us the lower limit if we do the subtraction. So 0.5598 minus 0.0297 gives us a lower limit of 0.5301. And for the upper limit, we'll have to do the addition. We will do 0.5598 plus 0.0297, and that gives me an upper limit of 0.5895. Part D, can you conclude that more than half of Americans want Congress and the President to fix the law a piece at a time? Yes. If you look at our confidence interval, the entire confidence interval is greater than 0.50. So more than 50% of Americans want to fix the law a piece at a time. Question 4. A smartphone manufacturer is interested in constructing a 90% confidence interval for the proportion of smartphones that break before the warranty expires. 85 of the 1,516 randomly selected smartphones broke before the warranty expired. In part A, let's look for a 90% confidence interval for the proportion. Recall the formula for the confidence interval. P hat plus or minus z times the square root of p hat times the quantity 1 minus p hat over n. Now in our particular problem, we can find the p hat by looking at x divided by n, or the number of successes divided by our sample size. That's 85 out of 1,516. This gives me a value of approximately 0.0561. We need to find z, and z we can get from our t-table. To find the column, we use 1 minus the level of confidence divided by 2. In our case, we have a 90% confidence interval, so let's do 1 minus 0.90 divided by 2, and that should give us 0.05. This is the column we need, and we need row z since the formula uses z. Our z is 1.645. Our z is 1.645, and we know the sample size is 1,516. So we have everything we need to plug into this formula. So we have p hat, which is 0.0561, plus or minus 1.645 times the square root of p hat again, which is 0.0561 times 1 minus 0.0561 divided by our sample size, which is 1,516. Now let's again focus on the right side of the plus or minus. And this gave me a value of 0.0097. So we can add and subtract this to our point estimate and we'll get our solution. So for the first one, take 0.0561 and then subtract 0.0097. This gives me a lower limit of 0.0464, and then we'll do it again, but this time use addition. Take 0.0561 plus 0.0097. This will give you an upper limit of 0.0658. So we're 90% confident that the proportion of all smartphones that break before the warranty expires is between 0.0464 and 0.0658. Part B. If many groups of 1,516 randomly selected smartphones are selected, then a different confidence interval would be produced for each group. About 90% of these confidence intervals will contain the true population proportion of all smartphones that break before the warranty expires, and about 10% will not contain the true population proportion. Now, just to make sure this problem is done correctly, let's go on to our statistics calculator and try it again. We'll use the calculator that says confidence interval for a proportion. Now the sample size was 1,516, and X we know is 85. I want a 90% confidence interval. Enter 0.90 and let's click calculate. Our lower bound is 0.0463 and our upper bound is 0.0658. Now let's compare that to the work we just did and let's see if it's correct. As you can see, our solution is very close to the computer's output, so this is a good solution.